At the beginning of the last lesson, I told you that the main objective of this unit is to learn how to solve quadratic equations. In other words, to find the zeros of quadratic equations. And I told you that there were going to be three main ways that we did that this unit. The equations we were given yesterday, it made sense to solve them using inverse operations. But the equations that we're going to be given today, it's not going to make sense to only use inverse operations, and you'll see why. So the way we're going to solve them today is by first completing the square, and then we're able to use inverse operations. So flip it open to page 8. And you'll see two equations on this page. Now, if I were to have you draw a line down the equal sign and cover up the right-hand side like we did yesterday, the problem with equations like this is that there's more than one x term. And you can't solve an equation using inverse operations when you have more than one x term. The reason we were able to solve using inverse operations during the last lesson is because when you covered up the right-hand side, there was only one x on this side. When you cover up the right side, there was only one x on this side. When you cover up the right-hand side, there was only one x. So because there's more than one x today, we need to change the form of the equation before we can use that process that we learned yesterday. But good news, the way we're going to change the form of the equation is by completing the square, which is something you already know how to do. Completing the square starts out with rewriting the equation with a giant space between these two terms. So we're going to rewrite this equation as x squared plus 4x giant space plus 3. And then we're going to add another giant space because remember, we'll add the magic number here and subtract the magic number here. So you also need to leave a little bit of space here. And then put your equal 0. Now, do you remember how to find what number we add here and subtract here? It has to do with this second term, this positive 4. What we do is we first cut that number in half. So 4 divided by 2. Because this is going to tell us what number you can add to itself to give you the second term. And that number is 2. 4 divided by 2 is 2. And then you want to square that number to figure out that number times itself. 2 squared is 4. So that means we're going to put plus 4 here and minus 4 here. And hopefully that feels familiar to you from the last unit. So now that we've done that, now that we've essentially added 0 to this equation, right, because we added 4 and subtracted 4, so that's essentially like adding 0 to the equation. But because we rewrote it in this way, it allows us to completely change the way the equation looks. Because we can rewrite this trinomial as parentheses x plus 2 parentheses squared. And remember, I just got this 2 from right here. Whatever number is in parentheses here gets put in parentheses here. And if you were to copy and paste that x plus 2 and then do your double distributing all the way out, you would end up with this trinomial here. And then we can just add this part at the end. So what's 3 minus 4? -1. Equals 0. And now, if I cover up the right-hand side of that equation, guess what? There's only one x. So now we can pick up where we left off yesterday. What's the first thing we're going to get rid of on this side of the equal sign. We're going to get rid of that minus 1. And the way we're going to get rid of a minus 1 is by adding 1. Bring down what's left, which is just x plus 2 quantity squared, and 0 plus 1 on this side, which is 1. So now, cover up the right-hand side. What are we going to get rid of next, the plus 2 or the squared? We're going to get rid of the squared next. And the way you get rid of a square is by taking the square root. So all we have left on the left-hand side now is x plus 2. And on the right-hand side, we have the square root of 1. Do you know if that one turns out nice or not? If not, type it in and find out. It does turn out nice. 1 is a perfect square. And the answer is positive 1 or negative 1. Remember, the answer to a square root is always the positive or negative version of that answer. So we're going to write plus or minus 1, because the square root of 1 is both positive 1 and negative 1. And our last step, if we cover up the right-hand side, the only thing left that's bothering that x is the plus 2. So to get rid of it, we're going to subtract 2. And when we do that, the only thing left is x. And x is going to equal plus or minus 1 minus 2. But remember, my advice to you is to flip the order of that. So to write it as negative 2 plus or minus 1. And then we're going to break this apart because there's two answers here. There's negative 2 plus 1 and negative 2 minus 1. Because we're trying to find the zeros of this quadratic. And the zeros happen in two different locations oftentimes. So our first answer is negative 2 plus 1. Negative 2 plus positive 1 is negative 1. And then we have negative 2 minus 1. Negative 2 minus 1 is negative 3. So this quadratic might look something like, it'd be really skinny. It would look something like that, where the zeros are negative 3 and negative 1. Let's move on to the second problem here. And I want you to cross out the problem that's in your packet and change it to this: x squared minus 6x minus 7 equals 0. So again, if I cover up the right-hand side, the problem with this equation is that there's an x in two spots. So we can't just start solving it using inverse operations. We need to rewrite it, and the way we do that is by using the completing the square process. So let's do it. Let's start by rewriting this with giant spaces between the second term and the third term, and another giant space before the 0. Because we're going to fill in a number here and a number here. We're going to add it here, subtract it here. And to figure out what that number is, we're going to be working with this second term, the coefficient on the second term, negative 6. First, we're going to cut that negative 6 in half. Negative 6 divided by 2 is negative 3. And then we're going to square it. So negative 3 squared. In other words, negative 3 times negative 3. If you're not sure, type it in. You get positive 9. So that is the magic number. That's the number that we're going to add here and subtract here. Plus 9, minus 9. because that's essentially like adding 0 to the equation. It doesn't change it at all. It just allows us to rewrite it in a way that's going to enable us to solve it. First, we're going to rewrite this trinomial. And we're going to rewrite it as x. Remember, I just grabbed the number from parentheses here and put it in my parentheses here. So x minus 3 quantity squared. And then, off the end, we're going to have whatever negative 7 minus 9 is. So negative 7 minus 9 is negative 16. So we're going to write negative 16 off the end. And now, if you cover up the right-hand side of this equation, there's only one x in one spot, which means we can use inverse operations to solve this. The first step is going to be to add 16. That goes away, and we're going to bring down what's left, which is x minus 3 quantity squared. And on the right-hand side, we have 0 plus 16, which is just 16. So now, if we cover up the right-hand side, what are we going to get rid of next? The minus 3 or the squared? We're going to get rid of the squared next by taking the square root of both sides. When we do that, that knocks out the square, so the only thing left is x minus 3. And on the right-hand side, we have the square root of 16. Maybe you know what that is, maybe you don't. If you don't, type it in. Square root of 16 is positive 4. But is it only positive 4? No, it's positive or negative 4. So we write it as plus or minus 4. And now, our last step is to add 3 to both sides. That will get x all the way by itself. So now, the only thing left on the left-hand side is x, and x is equal to plus or minus 4 plus 3. But remember, my advice is flip that around and write the 3 first, and then the plus or minus 4 second. And now we're going to break this off into the two answers, 3 plus 4 and 3 minus 4. 3 plus 4 is 7, and 3 minus 4 is negative 1. So if you were to draw a sketch of what this quadratic would look like, maybe it would look something like this, where it's crossing the x-axis at negative 1 and positive 7. Let's flip the page. We have 2 more to do on page 9. So, again, we have an x in 2 spots. That's what indicates that we need to use completing the square to rewrite this one. So, rewrite it with a giant space between our second term and our third term, and another giant space before the 0. To figure out what number goes in those spaces, we're going to take this 6, we're going to chop it in half, which gives us 3, and then we're going to square it, which gives us 9. So we're going to write plus 9 here and minus 9 here. And when we do that, that enables us to rewrite this in a form that we'll be able to solve. So we're going to rewrite these first 3 terms as the quantity x plus 3 squared. Remember, the 3 in parentheses here goes in parentheses here. And then off the end, we're going to have whatever negative 9 minus 9 is. Let's type that in because negatives are tricky. Negative 9 minus another 9 is negative 18. Equals 0. And now we're off to the races. Now we're going to solve this equation the way we solve every equation, by undoing everything that's around the x, starting with the minus 18. And we get rid of a minus 18 by adding 18. Once we do that, the only thing left to drop down is x plus 3 quantity squared. And on the right-hand side, we have 18, because 0 plus 18 is 18. Next, we need to get rid of that squared. And we're going to do that by taking the square root of both sides of our equation. When we do that, the only thing left is our x plus 3. Now, does the square root of 18 turn out nice? Is 18 one of our perfect squares, one of the 10 numbers we memorized? No, 18 is not a perfect square. What that means is that we need to tap into that knowledge we have from earlier in the unit, where we know how to rewrite the square root of 18 in simplest radical form. Now, for right now, my recommendation is to just leave it as positive or negative square root of 18. And we're going to deal with rewriting this later. But right now, it's just important to remember that there's a positive or a negative answer here. So we'll come back to that in a second. Let's finish up getting x alone by subtracting 3 here. And when we do that, x is alone. And remember, we're going to flip the order of these two. So we're going to write the negative 3 out in front, and then the plus or minus square root of 18 in back. And here's where we're going to simplify this. So think about how we would rewrite 18 as the product of a perfect square and another number. So in other words, we're on this step right here. Rewriting it as something times something. So think about your list of 10 perfect squares that we've memorized. What's the biggest perfect square that's smaller than 18? Do you know? It'd be 16. Does that divide evenly? No. So it's not 16. The next perfect square, as we head backwards, would be 9. Does that divide evenly? Yes. So we're going to rewrite this answer as 9 times 2. And then we're going to pull the square root of 9 out in front of the radical. So our final answer here is that x equals negative 3 plus or minus, do you know what the square root of 9 is? If not, type it in. 3. 3 square root of 2. And when you have it written in simplest radical form here, you don't need to break it apart. You can leave it just like this as your final answer. All right, let's do one more of these together. First step, rewrite your equation with a giant space between your second term and your third term. And then again, between your third term and your 0. To fill in that space, let's work with this 8 for a minute. We're going to chop it in half. 8 divided by 2 is 4. And we're going to square it. 4 squared is 16. So we're going to write plus 16 here and minus 16 here. And now that allows us to rewrite this piece as x plus 4 quantity squared. Remember, I just grabbed the 4 from there. And then off the end, we're going to have whatever positive 3 minus 16 is. Let's see, positive 3 minus 16 is negative 13. So we're going to have a negative 13 off the end and an equals 0. So now we know what to do. We're going to start by adding 13 to both sides. we're left with x plus 4 quantity squared on the left-hand side and 13 on the right-hand side. Next step, get rid of this square by taking the square root. When we do that, the only thing left is x plus 4 and the square root of 13. 13 is not one of our perfect squares. That one does not turn out nicely. So we're just going to rewrite it as plus or minus the square root of 13. Just like we did up here. Plus or minus the square root of 18, plus or minus the square root of 13. And the last step is to subtract 4. So, x equals, flip the order of these two numbers, so write the negative 4 out in front, and then your plus or minus square root of 13 in back. And now, can we simplify this the way we simplified our square root of 18? Let's see if 13 divides evenly by any of our perfect squares. The biggest one we can try is 9, and that doesn't work. And then we can try 4, and that doesn't work. So when this happens, when the number under the radical sign doesn't divide evenly by any of our perfect squares that are smaller than it, we get to just leave it as it is. This right here is our final answer. These are the two places that this quadratic function would cross the x-axis. So sometimes they cross nicely, like they did on page 8. And sometimes they don't cross nicely. And we have to rewrite our answer in simplest radical form. So I want you to get your homework packet out. We're on homework 4. And again, there's no back to this homework. There's just 2 problems I want you to try using what you learned today. Now you might notice the second problem looks a little different, so I'm going to help you get started on this one. We're used to seeing it set equal to 0 already, but occasionally it won't be. But how would you get this set equal to 0? If I drew a mini line down. If I want this side to be 0, wouldn't I add 7 to both sides? So when you do that, then your equation is x squared minus 6x plus 7 equals 0. And now you're off to the races. And now you would rewrite it with your giant space. X squared minus 6x, giant space plus 7, giant space equals 0. And you would use this term right here to figure out the magic number. Chop it in half, square it. So you have plus 9 here, minus 9 here. And now you're into the rewriting step, and this is where I'm going to let you finish. Okay? So see how you do on these 2 problems? Good luck.